Okay, so today in class we did part one of the lab titled Investigating Which Reactant is Excess. Typically, I call this the Limiting and Excess Reactant Lab. So if you see that difference in name, that's how I refer to it. If you have not read through the pre lab discussion, the objectives, and the procedure, please pause this video and read through it, and then answer pre-lab question number 1. I have uploaded the lab in Google Classroom. Please go on and just put your information or your answers on notebook paper. If you do not have a printer to print the lab off, notebook paper is perfectly fine, just like title pre-lab question number 1 or post-lab uh, or observation part 1, etc. Okay. So go on and pause the video if you have not opened up and read the lab, and then go on and answer question number 1. So the pre-lab question number 1 asks for you to calculate the number of moles in 2.65 grams of zinc. So this was a pretty easy one-step stoichiometry problem. How many moles of zinc are there if we have 2.65 grams of zinc? This number 65 came from the periodic table, rounding up the mass of zinc over 1 mole because your substances are the same in this equality. So you would take 2.65 times 1 divided by 65, and your answer is going to be 0.04077 moles of zinc. Calculation number 2 for the pre-lab question asks to calculate the number of moles of HCl in 37.5 milliliters if we have a 3 molar HCl solution. Okay, so that 3M, that capitalized M that's kind of like an italics, that stands for molar or your molarity. Okay, so again, it's read 3 molar hydrochloric acid. Again, that stands for your molarity. What does that mean? That means how strong your solution or weak. So the larger your number is, the stronger your substance is, or basically how concentrated your solution is, or what is the concentration of your solution. So this is a little bit of solution chemistry that we have not gotten into, and I want to stress this will not be on the unit test. If we were working with a 1 molar solution, this would be easy math to work with. Unfortunately, we had to have a stronger concentration to perform this lab to react with our zinc. So molarity, or this big M, the unit for it is moles over liters, so 1 mole per liter. However, when we're in lab, we're not measuring out liters because it's a large quantity. We're going to be measuring out smaller, so we're working with milliliters. So basically, if you have a 3 molar solution, that's going to be 3 times stronger than a 1 molar solution. So that's where I have the 3 moles. And we know that there are 1,000 milliliters and 1 liter. So this is going to be the equality that we're going to use to help us set up and solve number 2. Okay, so here is how you would set up and solve the pre-lab question number 2. How many moles of HCl are in, and we're measuring out 37.5 milliliters of hydrochloric acid, or HCl. Here's that equality that we used on the previous slide right here. That I discussed. So we would take 37.5 times 3 divided by 1,000, and you would end up with 0.1125 moles of HCl because your milliliters, they cancel out and you're left with moles. Calculation number 3, how many moles of HCl are required to react with 0.244 moles of zinc? So for calculation number 3, I gave you the balanced chemical equation for that question. So we have basically how many moles of HCl We were given 0.224 moles of zinc. Where did the 2 and the 1 come from? Well, they came from the coefficients in your balanced equation that's wrote on your paper. So your moles of zinc cancel. You're left with moles of HCl. So 0.224 times 2 divided by 1, and you get 0.448 moles of HCl. Hopefully, as you were looking through the Google Doc, you saw the images of the lab. Please make sure, if you have not looked at that Google Doc, if you could open it and read along the procedure that's wrote in the actual lab with the abbreviated procedure and pictures and video that I added, and use that information for your observations and data that you collected for part 1. If you have not done that, pause the video and do that before moving on to the next part. So in part 1 observation, whenever you went to go put the zinc and the acid together, hopefully you have realized that that you've done this reaction before. You did this in Chem 1. Where you were deciding on classifying what type of chemical reaction this is. And it was a single replacement. So you probably remember that, where you collected the hydrogen gas and then you lit the wood splint and you heard the pop. Same exact materials and chemicals. So when you put the zinc and the hydrochloric acid together, they reacted. You would see the reaction, the bubbling, the fizzing, the zinc kind of breaking apart, and the hydrogen gas and the water vapor leaving your solution in this test tube. If you felt your test tube, hopefully you noticed that it was pretty warm. So that was another sign that this was an exothermic reaction and it was giving off energy. Where did the water come from? Well, it came from within this reaction here, along with hydrogen gas that was being released, and oxygen and nitrogen. They are also part of the air. So this is for your observation, part 1, or question 1 and question 2. And if you could also look at the pictures in the Google Doc, that will also help you out with what you completed for part 1 of this particular lab.